What is thrust? It's a force, a very powerful push. It is what moves things forward. Specifically, it moves aircraft through the vast ocean of air against the constant pull of drag. Thrust is fundamental for the miracle of flight. Without it, aircraft stay firmly on the ground. Imagine a world without airplanes. Our connections would shrink, global trade would falter. Thrust makes our modern, interconnected world possible. It allows giant metal birds to soar. Without this essential force, aircraft are merely statues. An aircraft engine is like a giant breather. It inhales a massive amount of air. Then it exhales with incredible power. This powerful exhale is the thrust. Let us embark on a journey to explore this amazing force and understand how humanity learned to create it. Let's talk about Sir Isaac Newton. He gifted us the laws of motion. His third law is particularly crucial here. It states, for every action, there is an equal and opposite reaction. How do airplanes use this fundamental law? Aircraft engines are action machines. They take in air or sometimes hot gas. Then, they accelerate it. They push this mass backward with tremendous force and velocity. This backward expulsion of mass is the action. And what about the reaction? As the engine pushes the air backward, the air, in turn, pushes back. It pushes back on the engine, and therefore on the entire aircraft. This push is directed forward. This forward push, this reaction force, is what we call thrust. The airplane moves, it accelerates, it flies. Now let's venture inside an aircraft engine. The gas turbine engine is a common type. It is truly a marvel of human engineering. Many modern passenger jets use a specific kind. It's called a turbofan engine. These engines are the powerhouses enabling our global travel. A gas turbine engine works in distinct stages. First, there's the intake, giant fan blades at the front. They suck in enormous quantities of air. Then comes compression. The ingested air is squeezed by multiple stages of spinning compressor blades. This makes the air very dense. Its pressure and temperature rise dramatically. The next stage is combustion. The highly compressed air enters the combustion chamber. Here, fuel is continuously sprayed into it. This fuel-air mixture ignites, creating a controlled, sustained explosion. This generates extremely hot, rapidly expanding gases. Finally, we have the exhaust stage. The super-hot, high-pressure gases rush out, but not before passing through another set of blades. Section 4. Fueling the flight, the lifeblood of aviation. Engines, like all machines that do work, need energy. For aircraft engines, this energy comes from fuel. Aviation fuel is a very special concoction. For jet engines, we use highly refined kerosene. These fuels are commonly known by names like Jet A or Jet A1. What makes this jet fuel so special? One key property is its high energy density. This means it packs a lot of power into a relatively small weight, and also into a relatively small volume. This characteristic is crucial for aircraft. Planes need to carry enough fuel to fly very long distances without the fuel itself becoming too heavy or taking up too much space. Other properties of aviation fuel are also vital. A very low freezing point is essential. Commercial aircraft fly at high altitudes where the ambient temperature can be incredibly cold. The fuel must remain liquid. It cannot freeze or become waxy. This lifeblood allows engines to roar to life. Section 5. The sky's burden, environmental footprints of flight. Air travel is truly an amazing human achievement. It connects our world, but this convenience comes with consequences. Aircraft engines release emissions directly into the Earth's atmosphere. These emissions include carbon dioxide or CO2. CO2 is a major greenhouse gas. It traps heat, contributing to global warming and climate change. Water vapor is also a significant byproduct. When released at high altitudes, this water vapor can freeze, forming ice crystals. These create the familiar white streaks we see called condensation trails or contrails. Other emissions from jet engines include nitrogen oxides, often abbreviated as NOx. These gases can affect local air quality, especially around busy airports. They also contribute to the formation of smog and acid rain. Section 6. Greener skies ahead. The quest for sustainable aviation. The environmental challenge of aviation is clear. We need to make flying cleaner. Scientists and engineers around the world are working diligently on this problem. They are developing innovative solutions. One of the most promising areas right now is the development and deployment of SAFs, that stands for Sustainable Aviation Fuels. These are produced from renewable resources instead of fossil crude oil. These resources can include things like used cooking oil or waste from agriculture and forestry. A key advantage of many SAFs is that they are drop-in fuels. This means existing aircraft and existing airport infrastructure can use them without major modifications. Often blended with traditional jet fuel, SAFs have the potential to significantly cut carbon emissions from the aviation sector. Reductions can be substantial, sometimes up to 80% or more. This is measured over the entire life cycle of the fuel, from production to combustion. Section 7. Conclusion: Powering Tomorrow's Journeys. Generating thrust is a complex endeavor. Aircraft engine designers and manufacturers must constantly juggle multiple critical factors. They need immense power to lift heavy aircraft. They strive for maximum fuel efficiency to reduce costs and environmental impact. And above all else, safety is paramount. Modern jet engines are true triumphs of sophisticated science and brilliant human ingenuity. But the quest for improvement never ceases. We are witnessing constant advancements in engine technology. New materials are being developed and implemented, materials that are lighter, stronger, and can withstand higher temperatures. This allows engines to be more compact and operate more efficiently. The trajectory is clear, towards aircraft that are significantly quieter, substantially cleaner, and far more sustainable.